Okay, we're here with a video on identifying congruence. So what we're going to look at here is how to recognize congruent figures in general, but also how to choose the various theorems that we have for congruent triangles and when to use them. So we say that two figures, I've given two triangles here, but they can be any figures, are congruent if all their corresponding parts are congruent. So I will enlarge this a little bit so we can see. If we have something like this, now I'm going to mark the figure here in place of writing out givens. So let's say that we know that PA is congruent to BQ. And let's say that we know that MA is congruent to MB. And then let's say that we know that PM is congruent to QM. Let's say, for example, here we know we have some angles as well, that angle P is congruent to angle Q, and that angle B is congruent to angle A. And finally, we always know that these two are congruent because they're vertical angles. So PMA is congruent to QMB. So if we have this, now we can see in this picture, and it would be the same if we detached these two triangles, if the vertical angles weren't there, but we still knew that those two angles were congruent. We call these the corresponding sides. And these are, of course, your corresponding angles. These are, of course, different than corresponding angles for parallel lines. So this is not a transversal and what angles are in the same position. This is, we have two separate triangles, or any figure for that matter, and we know that we have a side in the first one that matches up with the side in the second one. We have an angle in the first one that matches up with the angle in the second one in such a way that they are congruent. If we have this, now we can see each of the three sides in triangle PMA matches up with each of the three sides in QMB, the angles as well. We can say that we have congruent triangles. We have two congruent figures here. And from that, we can write what is called a congruence statement. A congruence statement tells you what we have by their name. So we will say that triangle PMA is congruent to triangle QMB. And notice here how we said that P was equal to Q, the angles. They're the first two angles, right? And we said that the angle B was equal to angle A, and they're the last two. And we said that these, the two angle M's, were equal, and they're the middle. Of course, when we name the vertical angles, we use three letters, but we could still refer to each of them as angle M. So that's what it means to have congruent figures. Now, as we've seen in class, when we have triangles, there are a number of shortcuts we can use. We don't have to go and search for all these different pairs of congruent pieces. So, before we continue, we do need to talk about this idea of inclusion. If you have an included side or angle, it is the angle, for example, between two sides, or the side between two angles. So let's look at an example. We'll take our vertical angles here, and I can say that, actually I'll just use one. I'll say that angle PMA is included between PM and MA. and see how in this situation we have the angle. If you look at the way I've highlighted this, this is the angle that is sandwiched between those two sides. So it is included. For an example with a side, I can say that we have BQ is included between angles B and Q. So see there how, once again, we have side BQ is sandwiched between, it connects angles B and Q. It is an included side. We use those for 2 and technically 3 of our congruence theorems. So let's get back to the triangles. Name the postulate or theorem, SSS, SAS, ASA, or AAS, that can be used to prove the triangles are congruent. If they're congruent, tell us why. If not, write not possible. All right, and then again, remember that when we see these, A means angle, S means side. So let's take a look at these two on the left. All right, I know, and I would encourage you when you're doing these for homework or whatever to write this down. I know that angle ABD is congruent to angle CBD. That's given. Shown for us, they've marked it congruent. I know that where I see one right angle, I see two. So I know that angle BDA is congruent to angle BDC. All right angles are congruent. Now, this would look like a test problem. You would be given these things. You might be tempted to say, I can't complete this problem because I noticed that all of my shortcuts here have 3 letters and I only know 2 things here. But that's not exactly true. We also know that these 2 triangles share a side. They share the side BD. And remember that we can always say that something is congruent to itself. That's the reflexive property. And when you see these on tests or standardized tests, in-class tests, whatever, they will do that. They will not mark reflexive sides. They will not mark vertical angles. They're going to count on you to recognize that. Okay, well, let's look at what we have. We have 2 angles. The given angles, the right angles, we have one side. Okay, so we know that we can use either of these, angle, side angle, or angle, angle, side. The question is, which one do we use? Well, it's not exactly as we've written it. We have to go back to this idea of inclusion. So we see, and we should ask, is BD, our one side, included or not? The answer to that is no. Actually, whoops, looking at this one, the answer is yes. BD is between angles CBD and the right angle in this triangle. And the same is true on the other side, ABD and the right angle again, BD is between them. This one is angle, side, angle, because the side is included. And I can write that as triangle ABD is congruent to triangle CBD. And again, with that, please remember, your congruence statements should show the congruent corresponding parts. So angle A would be equal to C in this case, B to the other angle B, the 2 right angles, angle D. So that's how we do that one. All right, I'll erase my highlighting because we need it for the second one. All right, so let's look at the second one. We have angle B is congruent to angle Y. we have angle C is congruent to angle X. So we have two angles. Okay. Then after that, do we see anything else? Well, I see a side. So I'm going to say that side AB is congruent to side ZY. All right, so I'm going to use the same two. It's either AAS or ASA. So I'm going to ask the same question. Is the side AB and YZ included? The answer to this one is no. Those two sides are not between the congruent angles. So it's not ASA. In this one, I would say that triangle, they are congruent. Triangle BCA is congruent to triangle YXZ by angle, side, because the side there was not included. All right. The last one. Well, I know that JK is congruent to KN. We know that LK is congruent to KM. Those are my givens. I should mark my vertical angles. They're not going to be given to me. I can say that angle JKL is congruent to angle NKM. Those are your vertical. So I have two sides and one angle. Now, for this last one, I'm not going to use either of those two. I only have one angle here, so I can't use something that requires two. Okay. I'm also going to get rid of side, side, side. We can't just find congruent sides here. So we either have to be given or we don't have them. So it's either SAS or not possible. Why? Side, side angle is not a possibility. Write that the other way on your test and your teacher will probably send you to the dean for detention. Write it out on a separate sheet of paper and you'll know why. So it's either side angle side or nothing. So what we have to ask ourselves, similar to the question we asked ourselves in the first two, is angle JKL and angle MKN included? And the answer to this one is yes. We do have inclusion. It is between the two congruent sides. Remember, we saw that on the first slide that we looked at. These angles are sandwiched between the two congruent sides. So for this last one, I'm going to have to go above because I'm out of room. I'm going to say that triangle JKL is congruent to triangle NKM by side angle side, SAS. All right. So there's a run through of most of them. I didn't put a side, side, side here because that one is the easiest to recognize because it's all three sides equal. And there's no issues with positioning there because they're all sides.